All right, let's talk about one of the biggest, deepest mysteries in all of science. We're going to look at that exact, fleeting moment when the fuzzy, strange, uncertain quantum world suddenly snaps into the solid, predictable reality that you and I see every single day. And, for one of the first times ever, we can actually watch it happen.
So it all kicks off with a question that sounds like it's completely made up, right? Can a single thing, like a tiny particle of light, actually be in more than one place at the very same time? Well, quantum physics looks at that question, and the answer is a totally mind-bending, yeah, it can.
And this bizarre feature of reality has a name: quantum superposition. Now, the trick to getting your head around this is to stop thinking of a particle like a little billiard ball and start picturing it more like a wave of pure possibility, just spread out, existing in all its potential spots at once.
Of course, scientists don't just believe this because it sounds cool. They test it. And there's one incredibly famous experiment that just perfectly shows off all this quantum weirdness in action.
You've probably heard of it, the Double Slit Experiment. It's a classic for a reason. So if you shoot tiny particles at a wall with two slits in it, you'd expect to see just two lines on the screen behind it, right? But that is not what happens. Instead, you get this beautiful, complex pattern of many lines. And the only way that pattern can possibly form is if each particle went through both slits at the same time, like a wave, and interfered with itself on the other side. That's superposition right there on the screen.
Okay, so we've got the theory and we have the proof from the experiment. But what does it actually look like when one of these quantum states just falls apart? Usually when somebody explains this, you're looking at a cool animation or maybe a diagram. And don't get me wrong, those are great for understanding the idea, but, they're not the real thing.
But what you're about to see, this is different. This is one of the very first times that this whole process has been caught on video, in real time. This is not a simulation. This is the raw footage of quantum reality snapping from possibility into actuality. And now, for the main event. We are literally going to watch what happens when you poke the quantum world and force it to stop being so weird. To just pick a state and stick with it.
So how do you actually do that? Well, here's the setup. First, you start with that perfect wavy interference pattern. That's our proof that the photons are in superposition. Then you introduce just a tiny little interaction. In this case, some heat is applied right near one of the slits. And that simple act gives the universe what's called which-way information. It's almost like peeking to see which path the photon really took. And that one little peek, it destroys the whole quantum show.
And boom, look at that. The wavy, striped interference pattern just fades into nothing. All that beautiful quantum weirdness is gone. And what's left behind? Just a single, bright, kind of boring spot. It's a classical pattern. The photons aren't acting like waves anymore. They're acting like predictable little particles. The system was forced to choose, and it did.
So, what we all just saw, it actually has a scientific name. And no, it's not magic. It's a fundamental process of how our universe works. And getting the name right is pretty important.
That process is called decoherence. It's just what happens anytime a quantum system bumps into its environment. In our case, the heat we added. As soon as it interacts, it loses those strange quantum properties. Decoherence is basically the bridge connecting the quantum world to our classical one. And this gets to a really important point, the words we use to talk about this stuff. In pop science, we love to say a particle is in two places at once, but a physicist would more accurately call it an interference of probability. We might say the particle chooses a reality, when a scientist would say there's a concentration of probability. The language really does matter.
And hey, this isn't just me saying it. This is a vital point made by the scientists involved in this kind of work. Using language that sounds like magic is really tempting, but it can actually hide the real physics, which, frankly, is even more amazing. The truth isn't magic. It's just a completely different and wild set of rules.
So let's take a step back. What did we actually just see here? We really got a rare peek across the border, a look at the very edge of reality itself.
Look, this video isn't just a cool visual. It's a direct observation of one of the most profound puzzles in all of science. It shows us, right before our eyes, how the world we can touch and see emerges from a foundation that is just fundamentally uncertain and based on probability.
So the next time you look around you, at your desk, at your own hand, at anything that seems totally solid and real, just remember this. What you're actually seeing is the end result of this constant, unbelievable transition.
It's the transition from a world of infinite quantum possibilities into the single, solid, classical world that we all live in every single moment of every single day.